Right, last question I'm going to do today. Chord of contact, rectangle, hyperbola. Right, so again, this looked very similar to your tangent to the rectangle hyperbola, just like it did with the ellipse, just like it did with the hyperbola. The equation itself looked very similar to the tangent for the respective ellipse hyperbola. It's pretty much the same for the rectangular hyperbola. So there's the equation. So again, I can derive it, but I've already done a couple with the other conics. Right, so you just got to follow suit with the same sort of proof. So look at examples. P and Q. The P is 2P and 2 over P. Q, 2Q and 2 over Q. Are points on different branches of the hyperbola xy equals 4. Okay, so xy equals c squared. Remember the format of your rectangular hyperbola. So that's why it's 2 CP, C over P. That's why it's 2. We need to find the coordinates of the point of intersection of the tangent P and Q. So the point of intersection, sorry, type A is T. Because what we want to do is find the locus of T as P and Q vary, but the chord PQ always passes through the point 0,4. Right. So different branches. So we've got P over here somewhere. Got Q over here somewhere. Right, so we're going to draw two tangents. Okay, and the intersection of the tangent is that external point. And then we're going to have the chord of contact, but it always passes through the point 4 on the y-axis. Okay, so the point P and Q are going to change. That always goes through that point. We're going to see how the path of T follows. Right. Right, because you talked about tangent, so at the very worst, I should be able to write down the equation of the tangent that P and Q. So x plus p squared y is 2cp. However, we do know the value for c. Right, so we're not given it as a constant, we are given it as a number. Right, so c squared is 4, so c is going to be 2. So it's going to be 4p. Alright, so similarly, so x plus q squared y is going to be 4q. 1, 2. So we need to find the intersection of the tangent. So we need to solve the simultaneous equation. So if we can't get through the rest of the question, we should be able to at least write down the tangent at both P and Q, or derive them from there, and then we should be able to get at least the coordinates of the point of intersection for the tangent. So I'm noticing that the x variables here, which have got x and x, so I've got 1, take away 2, I'll eliminate the x variable straight away. So p squared take away q squared of y. Going to equal 4 outside of p take away q. So just factorising it as I'm going. So y is going to be 4 outside of p take away q over p squared take away q squared. Can't do any more with that. Difference of 2 squares, isn't it? Difference 2 squared. A squared take away b squared. And what that allows me to do is cancel it, which will help in the long run. Less expressions I have, the tidier it's going to be in the long run, that's for sure. Right, so put it in either 1 or 2 to solve for the x variable. Right, so x is going to be 4p, take away 4p squared over p plus q. So just rearranging, substituting, etc., etc. So 4p, p plus q, take away 4p squared, all over p plus q. Put over the common denominator, because again, it'll tidy it up nicely in a moment. Okay, so 4p squared plus 4pq, take away 4p squared over p plus q. Good, tidy it up a bit more. Okay, so I could use the chord of contact formula, however I'm just going to go derive it from here. So the gradient PQ, okay, so you guys could do it again if you wanted to. Just do it again. Alright, so 2 over P, take away 2 over Q, over P take away Q, so Y2 take away Y1, over X2 take away X1. Alright, so equal dot dot dot. This is going to equal -1 on PQ. Just so I can get this done. Right, so I want the equation of the chord PQ, and we know that it goes through 0, 4. So Y take away 0 is going to be -1 on PQ, Y take away 4, X take away 0. So PQ, Y take away 4 is equal to -x. So I haven't expanded yet, and there's a reason why. Alright, so the Y value, let's call this 3, and the X value that followed from that is 4. So Y is 4 over P plus Q, and X from number 4, X is 4PQ over P minus Q, P plus Q, so. Right, so we've got 2 sets of parameters we need to eliminate. Okay, we've got PQ and we've got P plus Q. Right, I'm actually going to do a double whammy. So from 3, P plus Q is going to be 4 over Y. Because I'm observing that I've got P plus Q on both these two expressions. So I'm going to substitute this into there, and then I'm going to have a PQ in terms of X and Y that I can substitute back up here and eliminate the parameters. Right, so that's number 5 into 4. So X is going to be 4PQ over 4 over Y. So we're eliminating parameters, that's why we are setting it up as we go. So this is really 4PQ times Y over 4. So the 4's cancel. So PQ is going to equal X over Y. So PQ is going to be X over Y. Okay. So what's that, number 6? 7 into 6. So, PQ outside of 1 minus 4 is negative x. So PQ y minus 4 is minus x. So x over y take away 4 is minus x. So eliminated the parameter, but we've just got to tidy it up a bit more. I'm going to bring this y up here. So x, y minus 4 is negative xy. So xy take away 4x is negative xy. So negative 4x is going to be negative 2xy. Y is going to be negative 4x over negative 2x. So the log is just going to be a straight line, y equals 2. Okay, but because back up here from the original substitution, we can't have a denominator of 0. Okay, so, well, it shouldn't matter actually. Y equals 2, what's that? That is that line. Y equals 0, so we can't. So y equals 2, y can't be 0. That's just the x-axis. It's not relevant then. Can't have y equals 0 anyway on the point.